So in this last section, what do we do if we have a hypothesis test for one population mean, but the population standard deviation is not known? Or we have a smaller sample than our normal size one that we can use our z-test with. What do we do? Well, this is just like we talked about last week. The logic was that we used a t distribution rather than a z distribution. Remember that the t distribution is like the normal curve. The only difference is that its size and its shape depends on the size of the sample that we're dealing with. Other than that, we basically do all of those same things that we've done before. The same logic that applies here applies for our t-values. Right? We're going to use our Excel program in order to help interpret this, but everything that we've said previously applies here. So we're looking for p-values that are either going to fall within our t-curve to the left and right of some fixed t-value, or that is a critical value here, or if it's a one-tailed test, to the right or the left of that critical value. And so our p-value falls within a certain region. We can reject that null hypothesis or not, depending on the kind of evidence that we see. So our procedure is very much like the last one. We're going to perform a hypothesis test for a population mean. Again, we assume it's a simple random sample and we're coming from a normal population or a fairly large sample, and that the standard deviation is not known. All right, so what do? We're going to set up our null hypothesis as we did. The null hypothesis is that the mean is equal to whatever claimed mean, that's mu0, we have. And our alternate hypothesis comes in one of three types. Either it's a two-tailed test, or it's a left or right tail test, in which case we're dealing with two different values on alpha, right? Our level of significance alpha is going to depend on what kind of result we want to get. How strong of evidence are we looking for to reject that null hypothesis? And we'll compute our t statistic in a way that's similar to what we've been dealing with in the past, but we will go and do that using Excel. And we could either use the critical value approach or the p-value approach, but the p-value approach, that's the one we're really interested in. So we're going to stick with that this time. We look for a t-statistics that has a degrees of freedom n-1, that is the sample size minus 1, and then we could use table 4 to estimate that p-value, but since our Excel does that for us, we'll go ahead and we're going to, as we did before, find that if the p-value from our test is less than alpha, reject that null hypothesis. Otherwise, we don't have enough evidence to reject it. All right, let's try this out. Let's say that in this case, we have we're going to do a sample, we're going to go for a sample mean. We want to test a sample mean hypothesis. And in this case, we're going to use our t-test to perform the required hypothesis test at the 5% level of significance. All right, so what does that mean? Well, okay, we've got our sample mean of 24. We've got a standard deviation from our sample of 4, but the sample size is 15, right? That's a relatively small size sample. Our claim is that the mean is 22, just like it was in the last case. Only in this case, our alternate hypothesis is a one-tail test. So we're going to go to a right tail test where the mean is greater than 22. And we want to test to see whether or not our data fits that. So let's go ahead and put this into our Excel spreadsheet to show what that looks like. This is this top test right here. Right? So you'll see that we have that small size sample, but we don't know the standard deviation from the population. So we're going to enter in our claimed mean from the sample from our hypothesis test, which was 22. And since we're dealing with a single tail test, a one tail test, and it's a right tail test, we make choice B in this case. Right? And our sample size, we said, was 15. We found a sample standard deviation of 24, our sample mean of 24, and a sample standard deviation of 4. Right? And we're setting our alpha level, because it's a one-tailed test, at 0.05. So the question now is, do we have enough evidence to reject? Well, we're going to use our p-value test. Remember that our p-value test said that if the p-value was less than or equal to our set alpha, we have enough evidence to reject. So our p-value in this case is 0.0366, so 0.037. So what does that mean? Well, from the perspective of conducting our test, if our p-value, get my pen here, if our p-value is equal to 0.037, let's say we round that up, our alpha level is set at 0.05, we reject if the p-value is less than alpha, less than or equal to alpha. And in this case, yes, we certainly have enough evidence to reject that null hypothesis. Right? And that's what we're after. This test will tell us whether or not we have enough evidence to say that. Well, this is certainly evidence, and relatively strong evidence. We could say moderately strong or even strong evidence, because our alpha level less than 0.05, we said that was when it was strong. All right. So this is the way that we're going to go about conducting these tests here. And we'll have a couple of worksheets that we can deal with on this during the week. So good luck, and I'll see you in class.